Hello everyone and welcome back to Java Forever course. Currently we are learning about functions, and in the previous classes we have learned a lot about different type of functions. We have learned about how to create functions, how to define a function, how to the signature of a function, how to call a function, how to pass the value, pass the parameters and all that. In today's class is a little different. When we talk about recursive functions, it's a little magical. The reason I say magical is a little different than what we have so far learned. Today we are going to learn how to call a function from within itself, which is very, very interesting. When you are defining a function, you are also calling that function in the program itself. You are not calling it from outside. The function calling the same function. It sounds like, if you have ever stood in front of a mirror and you held another mirror, it looks like, you have a mirror and then you have inside another mirror and you have another mirror and another mirror and another mirror and another mirror and so on, right? That is the whole idea. If I can use a diagram to show you, this is what a function calling itself looks like. Now let's take an example. I'm sure all of you have heard about factorials. Factorials in math is a pretty interesting concept in which we calculate, for a given number. Let's say we say number 5. We say this, that the factorial 5 is going to be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Factorial 4 is going to be 4 multiplied by 3 multiplied by 2 multiplied by 1. Now I'm going to stop here with these two simple examples. What's common between these two, if you notice, is that we are saying factorial this part is exactly the same as this part. That means this is nothing but factorial 4. So factorial 5 is nothing but 5 multiplied by factorial 4. Similarly, 4 is nothing but factorial 4 is 4 multiplied by factorial 3. 3 is factorial is nothing but 3 multiplied by factorial of 2. And you can see the only difference here is we are changing the number, but then factorial 5 contains a factorial 4 inside. Factorial 4 contains a factorial 3 inside. Let me draw another example in the same example, but a little bit bigger picture. Let's say this is factorial 5, which is 5 multiplied by 4, 3, 2 and 1. Now in this one, the factorial 4 is this. Inside this, factorial 3 is this green box. Inside this, I'm going to use a different color and say factorial is this. And inside this, let's say one more color, factorial of 1. Doesn't it appear like a mirror inside a mirror? Indeed, it does. So how we are going to solve it? We will write a Java code and we'll see it in action, how a function is going to call itself rather than giving 5 and let it calculate 4, 3, 2, 1. That's one way of doing it. You can write a loop and you can go down up to number 1 and do a multiplication. Or another way of is write a program that can calculate factorial of any number and it will call itself for the next number that is in the that's below the parent number. What I mean here is, let's take this example, and in this picture you will notice that we did factorial 5 here, and then we went to factorial 4, then we went to factorial 3, then we went to factorial 2, and then we kind of stopped here. The reason we call it base case is anything when you do like this, either you are in the loop or you are calling a function from within the function itself, you need to know when to stop and when to come out of it. Your base case is once we hit number 1, then we are going to stop. We will not go any further. And that is the time when you will calculate 2 and then return a value and multiply with number 3. 3 and 2. 2 is nothing but the value returned from the previous call. That gives you 6. The 6 is nothing but the value that you got it from previous call and multiplied by number 4. You literally stopped here and you say, you know what, Java, stop at 4, go and calculate factorial 3. At 3 you said, oh, 3, wait and go and calculate factorial of 2. But once you got factorial of 2, you need to start returning the value. And 24 is in the next call. Multiplied with 5 is what you return finally, 120. That is the factorial 5. Correct? So the way it looks like visually is you start here, you go down, go down, go down. And then when you start coming up, you start coming up, start returning the values. That is how it will look like. So let's take a look at the code. In this code here, you can see I defined a function called factorial, and it is going to give me a return value called int. And this factorial will take a number. It could be 5, 4, 3, 2, 1, whatever. And then I defined a variable that says, okay, this is going to be my final result. I always love to create a skeleton of my code by defining a function, the signature of the function, my return variable, and finally I'll return the value, whatever value I declared. My whole goal is to calculate that variable in my processing statements. This is my processing block. This is my output, and this is I'm returning the output. Now, since it is a function, it cannot call, it has to be called by somewhere. So we define another, static void main, that is the entry point. In this one, we are using a chaining. You can see that I'm starting with a factorial of 5. I'm calling this function, and whatever is the value, I'll print it ultimately. I could have put it into 2 statements. I can say int x equal to factorial of 5, and then I'll say print line. Again, I'm saving time, and say print x. I could have done it in 2 pieces, but you can see chaining in action that we already learned. But now let's focus on factorial itself. What is really happening in factorial is that we have a variable here. When we reach 1, then we need to stop it, because factorial of 1 is just 1. We don't need to call any more factorials because there is nothing after 1. That's the lowest number. So this I refer as base class. This is my base case. You should always identify your base case, that when will you stop calling yourself. But if it is not 1, then what do? I take that value and call the function again, but this time minus 1. So it was 5, then I'll call the same function with this time value 4. Next time the 4 goes inside, it will be 4 multiplied by value of 3. That is what this line is doing. So when they call, if you create a trace table, you will understand that in the first call, let's create a trace table. The value is 5 first time. So I called this with 5. Now, is value 5? Answer is no. It goes to else. What happens is it takes 5 multiplied by and calls the function again. So it's 5 multiplied by and then again call factorial of 4. And remember, I have not returned the value yet. I got inside this because I'm calling a function. But once this finally when the function returns, then it will come back and return me this value. Right now I'm not returning. I'm not able to return because immediately I'm calling a function also. So in this case, what will happen is it will again call the function, but this time value will be 4. So you call the function this time with value 4. So it will be 4 multiplied by, again you will call function of 3. 3 it will again call function of 2. And 2 it will call with function of 1, and this is where it's going to stop. What happens when you call with 1? When you call with 1, then it comes here and inside it says is 1 equal to 1? Answer is yes, it returns 1. Now this value is returned, let's say 1. So this whole thing becomes 2. This 2 value is returned in the previous function. This becomes 3 multiplied by 2. This becomes 6. This time the f3 is now 6. So this becomes 4 multiplied by 6. This becomes 24. And next time this becomes 5 multiplied by 24. As you can see, once you hit the base case, time to come back and return the values. And as the values starts returning, all the 4 calls that we have made it. We made first call, second call, third call, fourth call. Every call it starts returning value, and finally your code returns 120. Right? Very powerful, very interesting. You can see actually in real life the functions being used when you open your computer, right? And you especially on the Windows laptop, you see that you have a, one second, I just want to make sure that it didn't mess up. Okay, so when you open your laptop and browse the folders, what really happens is at a high level it shows you the name of all the folders, right? So let's say this is your folder. Inside this folder you may have more folders, but at some point of time you will say only files, and this is where you will stop. If your code, if you see only files, that means you are not going to process, you are not going to double click and open and see what is inside. You will stop it. This is a classic example of recursion. When you write code and you're trying to browse the files, when you find a folder, you go and call the same function and pass this folder this time. Next time you call this folder this time. Finally, once you start finding files, stop processing. This is your base case, and start returning the name of the folders and files inside. Right? You can go ahead and give it a try. You haven't learned yet how to read and find the files and folders yet. I'm going to do one more video down the line. Right now we are focused more on core Java, but the folder and files inside, you keep finding folder till you reach the files, and then you start coming back because there is no more folder inside. So the code you will write to process a folder, as soon as it finds another folder, you will call the same function again. Now let's take one more example. But before that, actually, I want to mention what is on the screen here. All recursive programs must follow these 3 simple rules. You must have a base case, otherwise you are going to run into infinite situation. Second, you must change the state and move forward towards the base case. Your goal should be to go towards your base case, right? Go towards 1. And third is you call yourself. Inside the function itself, you will call the function. Let's take one more example. I wrote a function called magic. What does this function do? I defined a base case here. If the number becomes 0, then just return 0. This is my base case. If number is not 0, then continue to process. And I'll call this function. And what I'm doing is I'm finding the modulus of the number, and I'm calling the same function magic on the number itself by dividing it by 10. Now let's see what will happen if I pass 6993 in and call this function magic. The first time when we pass 6993, what will happen here is this n is 6993. It comes here, this case is false, so it goes into else, and it gets this value, which is 3. It will return the remainder, plus it will give me 699, which is the whole number. And then it will call the same function again. So in the next call, it is going to be 6 and 99. In the next call, it will be 9, and plus it will return 9. Once this becomes 9, and remember, we have not returned the values yet. We are still here. When you pass 9, this becomes 0, and you get just 9 here. Sorry, this becomes 9 and this becomes 0. And you call with 0, then you will return 0, and this is where it will start returning 0. So it will become 9 plus 0, which is 9. It will return on the previous step. It will become 9 plus 9, 18. Then you will add 18 plus 6. Then you will add, which is 24 plus 3. It will become 27. So this method is actually nothing but finding the sum of all the digits, isn't it? And you can see, rather than finding numbers and going in the loop and all, we used the concept of recursion to find the sum of the numbers. Pretty cool. I really like recursion. It's very powerful once you learn how to use and where to use. Most importantly, where to use. With that, thank you very much. This was the last class on the functions. We'll start learning object-oriented programming. I'm going to create some more videos on that, and we'll have practice questions and quizzes for you guys. Happy learning, happy practicing. If you have survived this far, I must congratulate you. Thank you very much. Now you can apply this knowledge, whatever we have learned so far, in any programming language. I bet you will not need to take any other programming language class ever Whatever we have learned in Java applies equally in Python or any programming language. It's a matter of syntax now. Thank you very much. Love you all. Bye-bye.
Thanks for watching. Do subscribe and press the bell icon for more videos.